Hello and welcome to this first course. Today we'll speak about GIS data type and formats. The topics we are going to deal with are the main GIS concepts, raster and vector representation, and as well the most common GIS file formats. Well, first of all, let's speak what is a GIS. A GIS can be defined as a set of hardware, software, data, methods and people, and all of them has to manage, analyze and display everything that has a geographic reference. And if you speak about it, if you think each entity of land has spatial information, let's speak about environment, health, transport, and GIS allows us to visualize, understand, discover all the special relationship between geodata in form of maps, charts, reports and much more. So, as we have said, GIS is not only the software or the hardware, it's as well a set of data, people and standards working together to create a GIS. And what can be done with the GIS? We can map almost everything, let's say the position of things, the quantities, how density is something, what happens inside a specific area, so let's say about multi-temporal analysis, what is nearby, let's say what is the villages close to a river, to a road, and how change the phenomena during time. So a GIS integrates geographic information and not only in an only decision supporting system that represents a real world through data structured in layers, organizes data for fast and effective analysis, and provides tools for planning and management. We can analyze problems with water, roads, coastline, urban areas, vegetation and cadastre to solve problems like fire monitoring, pollution, forest management, agriculture, tourism and health. And a GIS works collecting data from different sources, store in a proper way, query them and analyze, and finally to show and produce final reports, maps and WebGIS. Let's see how we can represent geographic data. We can represent with different spatial data models. That means that are alphanumeric information linked to a specific location. So alphanumeric information is displayed on screen and they are related to the location of features in the real world. This is called data model. We have basic two main data models, vector and raster model. And all the spatial information is displayed in GIS using spatial layers. And a layer could be based on a raster on vector data model. So let's speak about a vector data model that is based on geometry type of point, polyline and polygon, and associated to each geographic information, there is a table storing alphanumeric information related with each of the geographic object. So each row of the table corresponds to one single spatial object. You see that as vector data model we can represent everything in the world, a field, a river, a road, some trees, and each of them can be represented as polygon, line or points. And how we can store and query the information? We have in relational databases and can be queried to different languages such as SQL that in GVSig can be queried through a user-friendly graphic interface. By the way, raster data model is based on grid of cells called pixel that make a representation of the real world, and a raster image stores numeric values for each pixel. So raster data model can be used mainly to represent continued features such as elevation, temperature or satellite images. What we have to know on raster data model: the origin, XY, is top left, the grid extent, I mean how many rows and columns are in the raster, and the grid resolution, the cell size, as well the georeferencing information. As I told you before, in the raster data model there is one digital number information, and in such an image, let's say digital elevation model, the digital number represents the elevation, for example. Here is a summary how we can represent the same feature in a raster or vector format. You see on the left, raster data, houses are just 1 pixel. On the contrary, vector data are point, and so on. So if we can resume, vector data are used to represent discrete data, such as trees, wells, roads, railways, and lakes, while raster data are used to represent continuous data, such as soil humidity, precipitations, elevation, and slope. Last topic is about the most common GIS file formats. If we deal with vector formats, the most common one is the shapefile. It's one set of files containing at least 3 files and stored in directories. We have .shp shapefile that stores vector information, dbf that stores attributes, and shx that stores spatial index. We can have more vector formats with different extensions, but they have to be named in the same way and stored in the same folder of the 3 previously mentioned files. Raster formats are data obtained by scanner or remote sensors, and mainly are TIFF, JPEG, or GeoTIFF, or GRAS, or as well grid format that belongs mainly to Esri. Well, I hope you enjoyed this first video on GIS data typing formats, and I'm looking forward to meet you in next the spatial reference systems. Keep in touch.